This is Dr.BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about the basics of kinetics, which has introduction, important terms, Newton's laws of motion, relation between force and mass. The course outcome of today's topic would be apply D'Alembert's principle to a dynamic equilibrium system by introducing the inertia force for knowing the acceleration and forces involved in the system. The topic covered would be kinetics, introduction, important terms, Newton's laws of motion, relation between force and mass. The topic learning outcome is application of D'Alembert's principle to engineering problems and know the effect of forces in the movement of the bodies. As we all know, the difference in the rigid body condition, where the rigid body is in rest condition and in the moving condition, whereas we will be calling them as static and dynamic conditions. In static conditions, we will be observing the objects not moving anywhere. That means the objects will be at rest. But in dynamic condition, the objects will be moving. So the first part of the mechanics which we have learned till now is of the static conditions, where the objects will not move, but we will be solving the problems related to the objects that are having or involving the forces in the system, and the movement of the object is not happening, only the objects are at rest. Whereas in the dynamic part of the mechanics, it is being divided into kinetics and kinematics. Kinematics is the process where we are not involving or we are not considering any forces that are being involved in the movement of the object. We all know that dynamic is the condition where the object moves, and we are going to study the characteristics of this object in the system in moving condition. That means the object will be having some velocity, time will be involved, and some acceleration will be coming into picture. Whereas the movement is needed a force for the cause of the motion. So any object to move, a force is required. So in dynamic condition, the objects will be moving because of forces that are being applied. So in this dynamic part of mechanics, we are going to see two different types, that is kinetics and kinematics. And kinematics is the part of the dynamics where we are not considering the forces that are involved for the movement of the object. And coming to kinetics, kinetics is the part of the mechanics where we are going to consider the forces that cause the motion. Time factor will be involved, velocity will be involved, distances, accelerations, all will be involved. Along with this, we are going to consider the force character also. So in any problem that is given in kinetics, all the movements or the motion of the object will be considered along with the force that is involved for the movement of the object. So now let us understand what the kinetics of the particle is all about. So kinetics is defined as the part of dynamics dealing with the interaction of mass, forces and the corresponding motion. So the important terms that are involved in the kinetics of the particle are, first one is matter. We all know anything which occupies space is called as the matter. And we have seen different types of matter such as solid, liquid and gas. So these are the three different types of matter that are present in the universe. So anything that occupies this space is termed as the matter. Then coming to mass, mass is the quantity of matter possessed by a body, and it is given in terms of kilograms. So mass can be identified or mass can be treated as the quantity of matter possessed by any object or a body. It is termed as the mass. Then coming to weight, force by which body is attracted towards the earth. So we all know that objects will be pulled towards the earth with acceleration due to gravity. Because of the acceleration due to gravity, all the objects, all the bodies will be pulled towards the earth. And this weight will be represented in the form of the Newton. That means this is treating as the equated value of the force. So weight can be considered as the force. Then coming to very important term, that is inertia. The property possessed by body by which it resists the change of state. This inertia term is being clearly understood using the Newton's first law, where the Newton's first law clearly explains the factor of inertia. Any body which is moving, or it will continue to be in its current state unless and until the forces are acted upon. Right? So the inertia of the body is the possessiveness of the state of condition, or continuing its own condition or character in which it is continuing. Then momentum. The quantity of motion possessed by body is termed as the momentum. It is measured by the product of mass and velocity. So momentum can be given as mass into velocity, where m is the mass and u is the velocity, initial velocity we can treat it as. So the momentum is defined as the product of mass and velocity. Now, before going into further topics of the kinetics, let us first briefly understand the Newton's laws of motion. What are the Newton's laws of motion that are given? Once again, we will be briefly recollecting the concepts. The first law, which is also treated as the law of inertia. So it states that every body continues in its state of rest or of uniform motion in a straight line unless it is acted upon by an external force to change that state. So as we have discussed, the first law will be stating the concept of inertia, where the object will try to continue in its original state, whether it may be at rest or whether it may be in motion. For changing this direction or changing the concept of the rest or motion, the disturbance is needed for the system. So that disturbance, unless and until a separate force or any external force is being acted upon, the object will continue to be in its original state of movement or rest. That is the Newton's first law. And Newton's second law, the rate of change of momentum of a body is proportional to the applied force and takes place in the direction in which the force acts. So this second law is used or utilized for deducing the equation of force, where the change of momentum of body is given as the directly proportional to the applied force. And third law, to every action there is an equal and opposite reaction. So these are the three laws that are proposed by the Newton, and these three basic laws forms the basis for our engineering mechanics. Now let us go to the relation between force and mass. We will be confining to the derivation of the force term here, where F is equal to ma is the equation that we are going to deduce. Let us start the derivation with m is equal to mass of the body. Any body that we are going to consider a body, and if we are treating a body of mass m, and a is the constant acceleration, and t is the time required to change velocity from u to v, right? So that means the object is moving and the initial velocity of the object is u and the final velocity of object is v. So the time required for this change in velocity is taken as small letter t. And F is the force applied. We have already discussed, for any object to change its velocity or change its direction, anything, an external force should be applied, unless and until it will be continuing in the same velocity, right? So the force that is applied in the system for the change in this velocity is F. From definition, the initial momentum is taken as m into u, where the momentum equation says it is the product of mass and velocity. So the initial momentum is related to the initial velocity into mass of the object. And final momentum is considered as m into v, where m is the mass of the object or body and v is the final velocity. So final momentum is mv. Now rate of change of momentum, nothing but the difference in the momentum from final to initial with respect to time. It's considered as the rate of change of momentum, and it is given as mv by mu, mv minus mu by t, that is equal to m into v minus u by t, where we are taking common the letter m or mass. So v minus u by t is treated as the acceleration, as we know, which is the rate of change of velocity, right? So v is final velocity and u is initial velocity. So the difference by time, v minus u by t would be the rate of change of velocity. So this velocity, rate of change of velocity will be the acceleration. So it is termed as m into a. So the rate of change of momentum is equal to ma. That is the final equation which we have obtained. From Newton's second law, we can say that force is directly proportional to rate of change of momentum, right? As we have discussed in the Newton's laws, force is directly proportional to rate of change of momentum. So this can be implied as F is proportional to rate of change of momentum, nothing but which we have obtained as ma. So F is proportional to ma. If at all we need to remove that proportionate thing, we are going to involve the proportionality constant, that is F is equal to K into ma, where K is the constant of proportionality. Now consider three cases here, A, B and C. In first case, as you are seeing, there is a mass of m. There is a body with mass of m kgs, and in the second case also there is a body of mass m kg, and third case body of mass m kg. Here this object is being applied by some force, let us say some force, and because of that force an acceleration of a meters per second square is happening or achieved by this object in case A. Also in case B, again force is being applied where a meters per second square is the acceleration that is being achieved by the object. In third case, there is again, because of weight which is applied in downward direction, there is an acceleration due to gravity that is given in terms of g, as g meters per second square. So in this situation, let us consider the equations. The unit force is so chosen that it will produce unit acceleration on a unit mass. Okay, unit force, as we have obtained in the previous section, the equation as F is equal to K into ma, we are considering that a unit force is applied such that it will be producing an unit acceleration, right? Unit acceleration on unit mass. So thus K is equal to 1. When we consider everything as unity, thus K is equal to 1. Therefore, F can be considered as M into A. So F is equal to MA, where F is the impressed or applied force which is given in terms of newtons, and M is the mass which is given in terms of kgs, and A is the acceleration which is given in terms of meters per second square. Now considering the frictional force or tractive force. So in this way, in the first case, we have obtained the equation for the force where the object M, object having mass M, is achieving a acceleration due to gravity of A. If we consider a unit mass and a unit acceleration due to gravity, the previous equation which we have obtained, that is F is equal to Kma, we have unified this K value. So the formula for force that is being applied, here would be F is equal to Ma. Now considering the second case, what we are doing is, here we are going to consider the frictional resistance where because of maybe the solid friction or the fluid friction, there is some resistance offered by the medium. Let us say the medium, resistance offered by the medium, force is being applied in this direction. So the acceleration due to gravity, acceleration that is being achieved by this object is a meters per second square. And the restriction or the resistance to movement is being considered here because of any frictional force, and that restriction is R. So here when you consider the whole thing, the object is moving in right side direction and the resistance is being taken in left side direction. Okay, so the applied force is being minimized, or it is being decreased because of the resistance force. So the total force that is being applied here in this system would be F minus R. That means total force, the actual force that is being applied for the movement of the object minus the resistance force, that is R. And that would be the value for the force, the ultimate force F minus R, that is equal to MA, which is the mass into acceleration. So considering the frictional force, the second case, considering the frictional force or tractive resistance, the net acceleration force is given by F is equal to MA plus R. That is F minus R is equal to MA. Then from definition, weight is force of gravity. This is regarding the third case where weight consideration is being taken and we are not applying any force, but weight is being considered as the force of gravity. Weight is force of gravity. So the net weight, that is therefore the weight which is in terms of newtons is given by mass m into acceleration due to gravity, that is G. So here the applied force would be directly the weight which is pulled by the earth, right? So weight consideration is taken, then W is equal to mg. So these are the cases and these are the relations between the force and mass which are related to independent way of moving the object and the frictional resistance in the weight that is being acted. Therefore, W is equal to mg is the final equation which we can obtain. Then motion of particle in rectangular coordinates, like how the coordinate system or how the directions and the involvement of the forces are being considered in the rectangular coordinates. If force and acceleration can be resolved along x and y directions, then Newton's second law can be expressed as sigma fx is equal to max in x direction and sigma fy is equal to may in y direction. Here, if you observe carefully, these are the conditions of equilibrium, right? These are the conditions of equilibrium where sigma fx are the forces that are in x directions, x-axis directions. Okay, so as these are the forces in x-axis directions, the ultimate equation would be mass into the accelerations in the x-axis directions. All the accelerations of the object in the all the connected bodies. Let us say number of bodies are being seen in the system, then the accelerations that is being achieved in the system is the acceleration that will be considered in x-axis direction. Similarly, sigma fy would be the forces that are involved in the y directions, and may would be the accelerations because of the force that is acting in y direction, the accelerations that are achieved in the system in y-axis direction. Okay, so in this way we will be considering the directions. As we know, the acceleration is vector quantity, that is, it is dependent on the direction. Here, all the forces which are acting in x-axis direction will give the accelerations in x-axis direction. Then all the forces which are acting in y-axis direction will give accelerations in the y-axis direction, right? So in this way we will be considering the motion of the particle in rectangular coordinates. This concludes the session. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.